So that's activation energy. Now keep in mind, we're going to be talking about activation energy more when we are actually, remember, in 2 weeks' time, you guys are going to be doing a criteria B and C. And the idea of activation energy will be quite important when we come to that. In fact, I might as well tell you right now. So that if you want to read ahead. The B and C will be based on 7.2 rates of reaction. Okay. In terms of how and what, Mr. Tilly and I will have to decide how to do that. Okay. So, but it will be on rates of reaction. Okay. So, now coming back here. Now, since today we're going to be talking about, we've done talking about activation energy, we're going to talk about heat of neutralization. So, before we get there, what is neutralization? What is neutralization, guys? What is neutralization? Yes?
I'm not sure, but I think neutralization has to do with making things having no reaction or making it equal.
Making it equal. Okay. So, making what equal?
The amount of bonds.
Not necessarily amount of bonds. Maybe it, I think, no, even in IB Chem, you're talking about electrons. So, not really about the bonds, but now, any ideas? Other people? What do you think you're trying to make equal? We're in a chemistry unit.
Chemical substances.
What chemical substances? What kind of chemical substances?
Reactants and products.
Acids.
Ooh, okay, acids and what's the opposite of acids?
Bases.
Base, good. We are trying to make acid and base, we're trying to neutralize them. Now, what is a neutral pH?
7.
7, oh good. Now, let me ask you this. When you neutralize acid and base, what are you going to get?
Water.
Water and? It's not just water.
Sodium?
CO2.
No.
Sometimes it's sodium. But sodium something.
Chlor.
So, sodium chloride.
Sodium.
Salt! Oh, good! So, acid-base neutralization, where if you actually put in the equal amounts or equal strength, I should say equal strength of acid and base, if you put in equal strength of acid and base, because sometimes some acids are stronger than the others. So you can't just say, oh, I'm just going to put 1 milliliter of this and 1 milliliter of that. It's not always that. You equal amounts or equal strength of both acid and base. When you do that, you will have water and salt. Depends on what kind of acid and base you're talking about. Next lesson, I'm planning for you guys to do an experiment on neutralization. Okay? And we'll measure the heat of that. Now, one thing is this. A neutral pH level is, just like what you said, it's a pH level of 7. Now, An acidic pH is it higher than 7 or lower than 7?
Lower.
Lower than 7. And base will be higher than 7. So good. You guys have learned that before or know it somewhere before. So an acidic pH is lower than 7 and basic pH is higher than 7. It depends on the textbook. Some textbooks go 12, some go 13, some go 14. I just say 14 for now. Okay? Okay. Now, what happens is this. Pretty much most, if not all, neutralization reaction, when you mix them together, mix acid and base together, it is almost always an exothermic reaction. It will give off heat. It will give off heat. So next week or next Monday, when you're doing the experiment, you guys are actually going to try to measure the amount of heat that is given off. So you can measure this heat that is given off, which is the heat of neutralization. And we are going to be using, I thought I have a cup in the front. We're actually going to be using these styrofoam cup, polystyrene or styrofoam cup. What's so good about styrofoam cups? I know that apparently they don't use it here that much, but I've been recently told they can get a whole bunch of them at Smoothie King and Jamba Juice. Maybe I should ask you all to bring your own cups. So, what's so good about these cups?
It keeps the heat inside.
It keeps the heat inside. So imagine if you're doing a reaction that releases heat, you're not going to lose it to the surrounding environment if you just use a polystyrene cup. Yes?
But what if we pour like hydrochloride and then it actually melts through the cup?
That's why I make sure that I use the chemicals that's not going to eat through this stuff. Okay? So if you turn and look at the back, you'll notice that there's a big canister of hydrochloric acid and there's a small container of sodium hydroxide. We're going to be doing experiment with that because, and this is the part, I'm going to start drawing some stuff. Now, because, oh, that's a corner. So, we're going to use these cups and we're going to pour in a known amount of HCl. Okay? The HCl, we know the amount as well as known concentration, which is 1 molar. Okay? Now, you're going to add also a known amount of sodium hydroxide. It will be in a solid form. Now, when you mix these two things together, as I said before, the neutralization reaction will happen. So when the neutralization reaction happens in there, it becomes an exothermic reaction. It becomes an exothermic reaction. It gives off heat to the environment. So it does give off heat to the environment. So it actually warms up the water that the acid is dissolved in. So this becomes warmer now. So how do you think we measure that? If something becomes warmer, the water becomes warmer, how do you think we can measure that? We put a thermometer in, yes. So we put a thermometer in there and measure the temperature. Do we just put the thermometer in at the end after we mix it in? David is shaking his head. Why not?
You have to find the difference.
You want to find the difference. So actually, you should put the thermometer. You should put the thermometer before and after. You put the thermometer in before you add the sodium hydroxide. So you know how much the temperature was of the acid. And you throw in or you add in the sodium hydroxide. It gets warmer. You can tell a difference. You put it in the thermometer again. You record the temperature. Good? And then you can actually use a specific formula known as Q equals mc delta T and be able to calculate the amount of energy. As you can tell, delta T is change of temperature. I'll tell you guys the rest when we're doing the experiment. Good? All right. So, what I will want you guys to do now, what I would want you guys to do is this over the weekend. Yeah, this is good. So, in your textbook, I'll zoom out. In your textbook, this section here. Now we're not going to do heat of. I'm not going to show you heat of combustion, but it's the same idea. Actually, you know what? Do the reading. You don't need to do the question itself about it. I want you to do the reading on heat of combustion because this is a good setup. And if you're preparing, if you're doing IB chemistry next year, I believe you actually do something along that line once. Okay, so look at this. Heat of combustion. Oh, this is in the fourth edition is page 149. Page 149. Yes, 179. Wow. Page 179. And then you see heat of neutralization. This part is actually what I was talking about earlier. You can polystyrene cup. Read through this. Also read on the activation energy. This goes in a little bit more detail than what I talk about in class. So just read this and then do these questions. You should be able to do these questions with no problem. Okay? Questions? Awesome. And you can even get a start on this now.